Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1442, count triplets that can form two arrays of equal XOR. This is a medium difficulty Leetcode problem, and the problem description tells us that we're given an array of integers called array, and we want to select three indices I, j, and k, and we ought to make sure that we define a and b as follows, where a, let's say we have 3 pointers, so we've got I, j, and k, like we're told. The first portion, A, just includes everything from array I to I plus 1, but not including j, and the second portion includes everything from j to k. And we should assume that these portions are XORed with each other. So we get the XOR of A and the XOR of B. And then we want to return the triplets, where if we were to XOR A and B, or sorry, we were to check what does A and B equal to, they would both be equal to the same number. So we want to make sure they're both exactly the same. Okay. So let's actually walk through an example as to how we can actually solve this problem. Well, let's say we have, let's just take this example over here, and we can see that they've given an output of 4 and there's 4 triplets, but it can be a bit confusing. So let's actually write this out. So we've got 2, 3, 1, 6, and 7. Okay, so let's say we have a pointer initially at I, and then j. Let's assume k is also at the same place that j is. So j and k are at the same index. So let's say we do let's assume XOR. Let's assume XOR is just some sort of black box that we don't actually know what happens here. It just does something and gives us a number. Let's just assume it's some sort of procedure for now. So XOR of 2 will just give us 2. XOR of 3, well, that just gives us 3, let's assume. So does 2 equal 3? Let's assume this part is A and this part is B. Well, no, it's not. So we're going to shift our pointer. So we're going to say, let's shift our k pointer to 1. Now, let's assume this part is A and this part is B. So we have A and we have B, and XOR of 2 is 2, and XOR of 3, 3 XOR 1 also gives us 2. Let's assume. So we have 2 equals 2. Does A equal B? Yes, it does. So this is a valid triplet. This triplet would be as shown here, 0, 1, and 2. But look at this. We have 0, 2, and 2. So what is this triplet? Why do we have another triplet at the exact same corresponding indexes? Well, we can also understand that, yes, if we had this equal to A and this equal to B, this works, but we could also rearrange this so that this part is equal to A and this part is equal to B. And they still are both valid. So if we were to XOR 2 and 3, we'll get 2, and we were to XOR 1, we also get get 1. So XOR 2 and 3 will get 1, and XOR 1 on its own will get 1. 1 equals 1. So this is also a valid number. These are also valid triplets. So really, we can kind of assume from this that no matter how we partition our triplet, we will be able to have it such that no matter the partition, where we partition exactly, A will be equal to B. So what we can also assume from this is, and if you're familiar with bitwise operations and specifically with XOR, this having some intuition behind this will be pretty cool. But it's something you can also figure out, and that is that if we were to, let's say we've got this triplet 2, 3, and 1. So we've got 2, 3, and 1, and we were to XOR them together. So 2 XOR 3 XOR 1, we would end up with 0. Now that's pretty cool, because that tells us if we have x1 XOR x2 XOR x3 XOR x4, it doesn't matter how long this is, and this ends up equaling to 0, well then no matter how we partition, it won't always equal to 0, of course, but if it does equal to 0, it means, let's say we partition this to be A, and we partition this to be B, or we partition this to be A, and this to be B, or we partition, this to be B, and this to be A. No matter how we partition, we will basically, we'll always get A equals to B. So just by XORing numbers together, if they equal to 0, well then the length of all the numbers in that XOR sequence is the number of combinations that we can perform such that A will equal to B. So we can say the length of, let's say here we have K, so index 2 and index 0. Well, 2 minus 0, let's just assume it's absolute, it's going to be equal to what? It's going to be equal to 2. And we know that there are two ways we can do this. We can do the indexes 0, 1, and 2, and we have the indexes 0, 2, and 2. So we can kind of use this intuition to solve this problem. If we XOR numbers together and they equal to 0, well, all the numbers in that sequence, all those combinations can be added to our result as triplets, or as basically as ways that we can, as number of triplets, basically. No matter how we partition those numbers in that sequence, every partition will be, whether that be A or B, will add up to 0. They'll all equal to each other. So let's actually get to coding this in Python. And again, I would definitely recommend looking up how XOR actually works, because this kind of problem and trying to find a solution for it is a bit complicated. There is a more complicated way, I believe, with a prefix sum and a hash map. You've got the simplest ways, like a big O of n cubed solution, which would be three for loops, and then you have it there. I do believe there is a big O of n solution as well with a prefix sum and hash map, but that's for another video because it is quite complicated. It's not the simplest of solutions, and you definitely ought to be familiar with prefix sum and hash map problem before actually delving into it with this sort of. It wouldn't even be a prefix sum; it'd be a prefix XOR, which would add its own complexities. So let's actually get to coding this. And actually, I believe a big O of n solution would be more of a Leetcode hard than it would be a Leetcode medium. But anyway, let's get to coding the current solution. So for I in range, we don't need to do length because we already got that. We want to start off on, we want to just do n minus 1. So all the way up to the end of n, but not the last element. And the reason we don't want the last element is because there's going to be no place for our j and k's pointers. So let's then have another loop, which is going to be equal to k. So this is going to be a big O of n squared solution. We don't really need to worry about j, because remember, with our intuition now, we don't need to add, we don't need to check I is equal to, j XOR k. We don't need to do that anymore. We just need to say, is it equal to 0? And if it is equal to 0, count all the potential triplets that we can have. So then we're going to say for k in range, we don't want to start from I, so we're going to say I plus 1 up to the end of our list. Okay, and what do we want to do as well? We want to have a current XOR variable. So current XOR is just going to be initially equal to 0. No, it's not. It's going to be equal to array of I. And this is going to be the element, the index, which I is at. And then we're going to say current XOR, let us XOR you by array K. So J is kind of implicit in this, and we are XORing our variable here. And if this current XOR ends up equaling to 0, if you equal 0, well, we know that there's multiple triplets in that sequence. So we can say result plus equals k minus I. So that length is going to be the number of triplets we can form. And then we want to simply return our result. So let's submit our code and let's check it works. And we get the wrong answer. Why do we get the wrong answer? Let's look through the code. So n minus 1 plus 1 to n. Okay, we're just XORing it, but we're not setting it equal. So we have to XOR and then set just how we would like increment with plus equals. So XOR equals is also an operation. And there we go. All 47 test cases have passed. So yeah, remember that if you are in an interview, if you have just XOR on its own, you won't actually set the value. You want to use XOR equals. So in terms of time complexity for this problem, guys, we're looking at a big O of n squared. So big O of n squared, actually big O of n squared, and space complexity is going to be we're just going to be big O of 1, isn't it? We have no extra space. So that's the time and that's the space complexity for this problem. Again, there are less optimal and more optimal ways to solve this problem, but I believe this kind of solution, although a bit hard to come up with at first, is the most intuitive and probably the simplest one to solve this kind of problem and to come up with, in a like a 20-minute time block. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.